Hello guys, today we shall be doing the reverse process of what we discussed in our previous video. If you are seeing this for the first time, consider joining my YouTube channel. Feel free to share, comment, and like the video. You can also subscribe to stay updated once we release a video. So today's class is going to be, we are going to be analyzing a mass on an inclined plane system. So remember, the assumption is still there's no friction, but this time around M1 is greater than M2. So we want to analyze that. So let's get started. So the first thing first, we are going to draw the free body diagram for each of the masses. A free body diagram is simply a diagram that presents us with all the forces that are acting on a body in a system. So that is what the free body diagram does. So the body here is mass. So let's start with M2. So the body here is M2. So let's start with M2. So what are the forces that are acting on M2? So that's the diagram. So according to this M2, we can see the tension force is pulling the M2 upward. So that's the tension T, pulling it upward. So that's the tension force. Now we also know that the weight of M2 is trying to drag it down. So we know that. But eventually, between the weight that is dragging the mass down and the tension that is pulling it up, we can see that one of them has the upper hand, which explains the direction of the acceleration in the system. So according to the direction of acceleration in the system, the entire body moved up. So which means tension has the upper hand. So if we want to find out the fraction that tension used to, pull this stunt, I can call that the resultant. We can establish that by subtracting the weight from the tension force. So we're going to put tension minus the weight acting downward. That should give me the resultant effect, which we can see. So if we expand on that, we have the tension minus the weight is M2 multiplied by gravity, and the resultant effect is M2 accelerating upward. So M2 times acceleration A. So that is it. So if we make T the Soviet formula, we can see that T is equal to M2A plus M2G. So that becomes equation 1. We can keep that in mind. So that is the tension that is on the M2. So that's the tension on M2. So moving on, let's analyze what is going on the body M1. So the free body diagram will look something like this. This is M1. So we can see what is going on with M1. So what are the forces that are acting on M1? So we can see the first force we are seeing here is the tension. The tension force, regardless of who is pulling who, the tension is pulling in the upward direction. So see the tension? Tension is pulling the M1 in this direction. So look at it. Tension is going this way. And as tension is going this way, something is also happening to this mass. The weight of the mass is not just the weight, because the weight of every object acts downward. The weight of this is acting downward, but it is not this weight that is acting downward that is causing the item to accelerate, but rather the component of the weight that is acting in this direction. So the component of the weight that is acting in this direction is the one responsible for sliding this M1 this way and dragging everybody with it. So that is what we need. We need this component. We don't need the weight. We need the component of the weight. And to ascertain this, we already know that if we drag this component, it forms an angle theta, which is the angle that is on the inclined plane. So this angle will tell us that this particular component is W cos theta, because wherever the angle is formed is cosine. Now the other side is going to be W sine theta. So we already know that. So this is the weight component that is pulling this way. Now, between this weight component and the tension, who has the upper hand? You can see that for yourself. It is the weight component. So in that case, we can say the weight component, W sine theta, remove the tension, we can see the resultant effect that is used to pull the whole system down the hill. And that resultant effect is M1 multiplied by the acceleration, A. So we already know the weight is M1 times G sine theta minus T, and that is that. m1 times a. So if I make T the subject formula, we can see that m1g sine theta minus m1a is equal to the tension T. So that's it, just moving things around. M1a come over here, minus T goes to the other side, and that is what we have. So this is the tension for the case where m1 is greater than m2. So the same case, we can combine these two equations together to ascertain the acceleration in the system. So the acceleration in the system can be obtained by combining them together. So the tension on the two are equal while the object is accelerating. So if we combine it, we're going to have m2a plus m2g is equal to m1g sine theta minus m1a. So collect the like terms, we have m2a plus m1a. Just subtract this one, add m1a on both sides so that it will be eliminated here and appear here. Then for this, we'll subtract m2g from both sides so that we'll have m1g sine theta minus m2g. So we're making a headway. So here we can factor out at the acceleration. So if we factor out acceleration, and we're going to have something like this. So let me wipe to some of the space here so we can see what we're doing. Let me wipe this. So if we factor out what we have here, we can see acceleration all into m2 plus m1. You can write m1 plus m2 regardless of how you are putting it. So that will be equal to m1g sine theta minus m2g. So that is it. So we can divide both sides by the coefficient of the acceleration, which is m1 plus m2 divided on both sides. So I'll divide m1 plus m2 here. And I'm also going to divide that m1 plus m2 there. So that's this. Take care of this. The acceleration will now become equal to m1 g sine theta minus m2g divided by m1 plus m2. So that makes sense. So we can see this is the acceleration in the system. Now, if you saw the previous video we did, you can agree with me that there is just a slight difference between what is happening now and what we established in our previous video. Now, you have to get this. So from our previous video, we established that acceleration is given as m2g minus m1g sine theta divided by m1 plus m2. This was the case where m2 is greater than m1. So that's where we saw this. And then this one is a case where m1 is greater than m2. So what do you see here? What's the common thing that you can see here? Now you can see that the common thing here is, you know, that the mass times gravity gives us the weight. So it's telling us that whenever one of the masses in the pulley system here is greater than the other, we subtract the lesser mass, the lesser weight, from the higher weight to obtain the acceleration. Look at it here. The weight m1 was subtracted from the weight m2, and we divided by the sum of their masses to obtain the acceleration when m2 is greater than m1. And you can see that the reverse was put in place for this case where m1 is greater than m2. So that is the important equations that exist as long as a mass on an inclined plane is concerned. Remember, we are assuming there is no frictional force. So what if there is frictional force? What is going to happen? If there exists a frictional force, it is only going to affect the mass that is resting on the inclined plane. Frictional force will not affect this one that is hanging freely in the air. It's only going to affect this one. So I want you to try and include friction in your derivation and tell me what happens when there exists a frictional force. So till then, see you.